Welcome to the WIONPodcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore how an invisible fault line silent for centuries could trigger the next mega earthquake in Istanbul region, and what it means for millions of lives. What makes this threat even more alarming is how long it has been quietly unfolding beneath the surface. The North Anatolian Fault, NAF, beneath the Marmara Sea near Istanbul, Turkey, hasn't had a major quake in more than 250 years. Stress is building right underneath it, while surrounding sections have ruptured towards the west, triggering devastating earthquakes. Researchers from the Institute of Science Tokyo used electromagnetic X-rays and were able to map the invisible structure of this fault. The 3D model reveals high-stress zones where tectonic plates are physically jammed together. The study was published in the journal Geology. Many scientists believe this section under the Marmara Sea is most likely the site of the next major earthquake. Istanbul is merely miles away and sits in the eye of the storm. This map is a race against time to predict exactly where the crust will finally snap. For years, scientists have tried to create a detailed structure of the fault below the Marmara Sea. In the absence of a clear picture, the ability to accurately identify where future earthquakes might begin has remained limited. Dr. Yasuo Ogawa, Professor Emeritus and Research Fellow at the Multidisciplinary Resilience Research Center, Institute of Integrated Research, and Dr. Tulay Kaya Iken, Assistant Professor at Boğaziçi University, Turkey, investigated the section under the Marmara Sea to remove the gap in knowledge. Together, they were able to create the first full three-dimensional model of this crucial subsurface area. Using magnetotellurics, a technique that measures subtle changes in Earth's electric and magnetic fields, they built the first 3D map of the North Anatolian Fault's resistivity. They identified areas where the rock is rigid and where it is weakened by fluids. This helped them locate locked zones where immense stress has built up. These boundaries are likely where the next major rupture will begin, providing a new blueprint for disaster mitigation in Turkey. We believe the resistive anomalies observed signify regions of stress accumulation, shedding light on the ongoing processes of fault mechanics at play in this critical region, Ogawa said. Referring to their findings, the researchers believe future large earthquakes may begin at the boundaries where weaker and stronger sections of the crust meet or along the edges of highly resistive zones. Ogawa added, "Our results can be used to estimate the location and potential magnitude of future megathrust earthquakes, with significant implications for disaster prevention and mitigation." Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.